the Global Ocean Observing System Program Office, which is based at the Intergovernmental Oceanographic Commission of UNESCO in Paris. But today I'm sharing moderating duties with Katie here in Geneva. Katie?
Hello, my name is Katie Hill. I work in the Global Climate Observing System Office. I'm here at the World Meteorological Organization in Geneva, as well as providing support to the GOOS program. And during the next hour, we will start with an approximately 30-minute presentation from Lisa Levin. Lisa is professor at the Scripps Institution of Oceanography at the University of California in San Diego. And Lisa is also leading the development of the Deep Ocean Observing Strategy as a project of GOOS. GOOS is focused on development of common requirements and an initial strategy for implementation of sustained global deep ocean observations, considering all essential ocean variables and regions. GOOS focuses on observations in the deep ocean to address the grand societal issues of climate change prediction, adaptation, ecosystem conservation, and sustainable management in the deep ocean. After Lisa's presentation, we will conduct a question and answer session by the chat, so feel free to put some questions in the chat screen, and we will moderate and select those questions to ask them verbally. The chat window will be open during the presentation if you'd like to start asking clarification questions. This session will be recorded, and the link to the recording will be posted on the GOOS website. Great, so over to you, Lisa, for your presentation, and we will mute ourselves.
Okay, thank you, Albert and Katie. Hope everybody can hear me. It's my pleasure to be able to introduce the Deep Ocean Observing Strategy to those of you who don't know about it, and to clarify what's been happening. This program is the newest GOOS subprogram, so it's housed within GOOS, but it is partnering with the Deep Ocean Stewardship Initiative, in part to focus on observations in the deep ocean that help us to address the grand societal issues that we face. And I've listed some of them here: climate change prediction and adaptation, ecosystem conservation, and sustainable management in the deep ocean, and actually much more. Now let's see if I can advance. So what I'd like to do in the webinar today is to give you a little sense of how this program came to be, its history, talk about the motivators and rationale for deep observing, talk about what the Deep Ocean Observing Strategy actually is with the terms of reference. I want to mention an inventory that we've been conducting on deep observing, and then spend quite a bit of the time focusing on or providing you an overview of a workshop that was held in December of last year to try to scope out this program, and then give you a sense of what actions we intend going forward. I keep advancing the wrong button here. All right, so before the workshop, an objectives or mission statement was created, and I think it's still a good fit for the program. And this is to develop a common statement of requirements and an initial strategy for sustained global deep ocean observations, considering all essential ocean variables, regions, technologies, and societal imperatives, so as to extract high priority feasibility and GOOS fit for purpose actions for the next 5 to 10 years. And this is really quite a mouthful, but there's quite a lot to be done. I should say that while the GOOS programs do tend to focus in the 5 to 10 year range, I think most people will agree that the challenges we face and the motivators for observing the deep ocean are really century-long issues. And so I think it's what in my view, this program will be doing is setting the scene with baseline observations that will look out for the next 20 to 50 years or more. So I am going to start with more or less the punchline of the presentation. For those of you short on time, this is really the guts of what the Deep Ocean Observing Strategy is. These terms of reference were evolved and developed at the workshop last December, which I'll talk more about. But really, the program is designed to build understanding of what is most important to observe in the deep ocean. In other words, to identify the key science and societal questions and relevant variables, to provide a hub for integration opportunities, that is, to coordinate existing deep observing activities across disciplines, to link different research programs, different agencies, and to foster multidisciplinary observing. A related goal is to coordinate observations. Perhaps on a smaller scale, we're looking at utilizing existing platforms for new and integrated sensors, or and to try to document the status of deep observing, as well as develop standards and best practices. Key to all of the GOOS programs is to develop observing requirements. We will do this to identify deep essential ocean variables, the gaps, how they relate to the rest of the GOOS EOVs. We'll look at emerging systems and develop specifications for these variables. Another goal is to build readiness in observing technology and techniques, and to promote new technology developments, assess their suitability, and to promote usability. In other words, looking forward to what we need to do to observe the deep ocean. Another is to foster availability, discoverability, and usability of deep ocean data. And then finally, to create a common community science implementation plan for deep ocean observing that advocates globally for deep observations. So that's a lot. That's really, at the heart of what the deep ocean observing strategy is. Now I want to go into many of the details, how we arrived at this, what the thinking and motivators are for this program. And I'm going to start with the question of what depths is this program addressing. Believe it or not, this was a fairly controversial issue among the planners. And I would say it's fair to say that the physicists have successfully measured many ocean variables to 2,000 meters using Argo, and as a result, their focus is on below 2,000 meters with new programs like Deep Argo. But many of the biologists and biogeochemists measurements focus only on the surface ocean, or perhaps to 500 meters. There are many gaps, and we know that there are very key biological processes and transformations that take place between 200 and 2,000 meters that ultimately influence the phenomena and processes of interest in the deeper waters. And so what we have more or less arrived at is an agreement to focus the deep ocean observing strategy below 2,000 meters, but to include observations that help explain the processes that may occur in shallower waters, anywhere below 200 meters. So that's sort of where we are with the depth question. And let me give you just a little bit of sense of how GOOS evolved. The consultative draft, a first document, was led by Eric Lindstrom. This was really his brainchild, and he assembled a team of about 10 people in 2012 to start preparing this draft. It wasn't until 2015 that this really came together and was completed. A leadership team was formed, and in 2016, the consultative draft was put out for community feedback. A deep ocean observing inventory was conducted, and a scoping workshop for the program was held in December. And so where we are now is, as you'll see, we're really still spinning up and developing an implementation plan, ideally for sustained observations into the future. To give you some sense of who was involved, many of the people on this list here on the left were involved in writing the original consultative draft. Others joined the group to help plan the scoping workshop held last month. And I'm happy to announce that Patrick Heimbach and Henry Rule are joining me as sort of a triumvirate to help lead this program. We also have a distributed project office with Andrea McCurdy as the project officer. The three folks you see listed there, Nick Crudy and Kristen, in the Consortium for Ocean Leadership helping out, and then we have Leslie and Guillermo. On the left, we have a variety of people who played roles up till this point. Some are taking on other jobs, but I should say that the Deep Ocean Observing Strategy is now in the process of forming a steering committee, and if there are people who would like to participate, please let us know by contacting Andrea McCurdy at the, I guess I can point here. Can I point? Maybe not. Anyway, at the email address you see there. So what is the Deep Ocean Observing Strategy? Well, initially it was intended to bring together the sustained long-term observing programs that we have out there. These include GOOS, some space observations, the many Argo programs, some time series like Cal Coffee, for example, moorings, smart cables, gliders, and observatories. But it became clear that there are many other sources of ocean observations, and I think the intent is to expand to include deep submergence vehicles, animal tagging, passive and active acoustic measures, other new innovative molecular instrumentation. So the goal is to be very inclusive in terms of what's out there making measurements and observations in the deep ocean. Now, the next few slides I want to show you really discuss the motivators for this program, and I'm going to start with physics. We know that information about the deep ocean is required for the scientific understanding of the Earth system and for improved decision by policymakers. Really understanding how much heat the ocean is taking up and where it's taking up and how much is ending up in the deep ocean is vital to understanding and predicting how fast the Earth is going to warm with increased greenhouse gas concentrations. So part of doing this involves closing the heat and freshwater budgets of the ocean, understanding the warming and ocean freshening processes and how these contribute to sea level rise. Key to all of this is understanding the global overturning circulation, the processes of ventilation, which we measure with tracers, and to understanding small-scale processes like turbulence and how these affect the bigger budgets. So these are really the physical motivators, but beyond the physics, we have quite a number of international entities that have a stake in or that are affected by deep ocean processes and ecosystems. And the activities of these organizations will benefit tremendously from deep observing. And I don't have time to go into them all, but we have sort of on the right side here, the resource agencies like the International Seabed Authority that regulates deep sea mining, and the fisheries, the FAO and RFMOs that regulate high seas fisheries and deep water fisheries. On the left, we have the biodiversity conventions like the CBD and those that regulate endangered species. And all of these stand to benefit from enhanced deep observing and in fact need more deep ocean observations to do their work. I think these societal imperatives are increasing because the ocean, deep ocean, is increasingly subject to extraction of resources through deep sea fishing, through deep water oil and gas drilling, to some extent through removal of genetic resources, and we're really poised to do deep sea mining for a variety of resources in many different settings. And in the management of all of these activities also will require additional deep observing. I've mentioned climate issues initially. I think that we're in a place now where there's a need to bring together knowledge of climate change and ecosystems to address some of the conservation and stewardship challenges that are posed by growing human activity. So we're in a place where we need the observations of climate variables to do marine spatial planning, to develop regulations for these new deep water activities. Climate policy itself and the UNFCCC is very focused on questions that will benefit greatly from deep ocean observing. The climate negotiations and Here you can see at the Scripps booth on ocean observing, and we highlighted the importance of deep water at the last COP22. But in addition, the IPCC puts out their regular reports, and then it's now putting out a special report on oceans and cryosphere. And I'm hoping that deep ocean observations and deep ocean data will play an important role in this report. Oops, let's go back. Beyond climate and some of the regulations, we have the Sustainable Development Goals. There's a lot of focus on Goal 14, which involves conserving and sustainably using the ocean, seas, and marine resources for sustainable development. And once again, from what I've said, I think it's very clear that deep ocean observations will ultimately be very important to achieving Goal 14. And I want to close in terms of motivators with biodiversity. This often underlies much of the stewardship focus. And it's fair to say that this is one of our greatest challenges in the deep ocean. If you look at biodiversity observations here, you can see there's a thin skin of observations at the very surface and a little bit on the bottom on the shelf and upper slope. But most of the deep sea is very poorly observed. And when Ward Appleton's gathered up continuous or 5-year time series data in the Ocean Biogeographic and Information System, we find that there are 66 times more observations above 200 meters than below 200 meters. And I think this just tells us how limited our deep observing has been to date in terms of biodiversity and biology. So what is the deep ocean observing strategy? I think for now I want to tell you where we are. We have a web page and at deepoceanobserving.org. I'd encourage everybody to go look at that. We have a consultative draft, which was written before the workshop and is, I think, the precursor to the implementation plan. We have an inventory that I'll talk about, and we've had a workshop that's tried to focus the efforts of this group, of this program. So I don't actually have a lot of time to talk about the consultative draft. I will say that it's got this material in it, and I would direct everybody to the website to have a look at it. We're still taking input. The strategic roadmap needs to be rewritten to align itself with the scoping workshop recommendations. There was a deep ocean observations inventory that was conducted initially is starting in August, and it's been ongoing. We're still taking inputs, but Leslie Smith's been working on this. We had initially 70 responses from 39 organizations in 83 countries. We think it's the first attempt to collect this information. Many of the projects, over 3/4, were projects that covered a very broad depth range, often down to 4,000 or 6,000 meters. And a very broad spatial scale. The key platforms identified were research ship surveys and moorings with bottle samples taken from the ships. The key instrumentation, not surprisingly, were CTDs, oxygen sensors, and ADCPs, and the most common EOVs measured were temperature, salinity, dissolved oxygen, carbonate system, and primary productivity, with many others recommended by people. Leslie has been working on creating an iterative or an interactive map, I should say, that plots deep ocean observations. If you go onto the web address you see here, you can look at it. If you hold your cursor over the points, you can learn more about the observing programs and being directed to their data and websites. So here, for example, you see the Argo floats in black specks and the ocean sites moorings in purple, and many of the other deep observing programs that responded to the inventory in green. And we hope to grow and continue with this inventory. So by all means, if you don't find yourself on here, please contribute. For the rest of the presentation, I'd like to talk about the scoping workshop that we held at Scripps last month. There were about 40 people from roughly 10 countries represented. It was a relatively small workshop. The goals were to encourage increased partnerships across the deep ocean research community, to improve the readiness levels of requirements and technologies and platforms and data for deep observing, and to expand, in particular, to expand expand the global ocean observing system community to include a more diverse, deep group of stakeholders. And of course, really we viewed this as a scoping workshop with the intent of defining what should the deep ocean observing strategy do and be. So the very first thing one of the very first things we tried to do at this workshop was to identify key science challenges. And the list of 7 items, I guess, that you see here is what the group came up with. They focus on Earth's energy imbalance and land-sea water distribution, on global meridional overturning circulation and its variability, on quantifying carbon budget, deep ocean carbon uptake and storage, and the impacts on acidification and deoxygenation, as well as the biological pump and sequestration. Another focused on the role of geofluxes across the seafloor and their importance relative to other processes, also geohazards and early warning and timeliness of the warnings. Another focus on the functional importance of the animals and microbes in the deep sea. And then a final one on ecosystems in the deep pelagic and how they respond to climate change, associated changes in ocean properties and direct human activities. So the group basically started with a very long list and consolidated them down to these 7. We didn't have very good representation of earth scientists at this workshop, and so when we broke out to consider these, we were not able to address those focused on earth sciences. I'm not going to have time to talk about all these in general, but the group addressed the essential ocean variables for the deep ocean. They're not exactly the same as they are for the rest of the GOOS programs. There are some additional things, but I would say these are still very much under discussion, and if any of you are interested in participating in working groups in any of the physical, biogeochemical, or biological areas, please let me know. The biologists in particular added a number of new items to their list. Ocean sound, for example, sediment community oxygen consumption, and some other things. And there is overlap. For example, some of the biology EOVs really belong in the biogeochemistry section, and we need to engage in conversation with the biogeochemists about this. So I would say the essential ocean variables are in progress. Many are still under discussion. They need specs. They need a very thoughtful and careful treatment, which I'm hoping there will be some working groups within this program developed to address these. Now, I'd like to talk just a little bit about the breakout group discussions. There were 4 groups that tackled those major science questions that the workshop came up with. And the first of these groups tackled global energy imbalance and overturning circulation. These were put together. The physicists met and talked about the importance of constraining Earth's energy imbalance and the land-sea water distribution and the overturning circulation for understanding deep water formation, for deep ocean mixing, geothermal heating, and impacts on deep ecosystems. So they discussed what kinds of observing systems could be put together to address this: deep Argo floats, turbulence measurements, the mooring, satellite observations, and also under ice observations. And they also agreed that a focus on western boundary currents would be very helpful. A second breakout group addressed carbon flux and storage issues, talked about how to constrain the carbon cycle and the role of the deep ocean. They came up with the need for carbon inventories in the deep ocean for measuring variation in the biological pump and remineralization and sequestration processes, and for making high-frequency EOV observations from fixed-point reference stations. And they have a whole slew of methodologies and approaches, inventories, in situ measurements, ways to improve use of the mooring systems to collect EOV information. They have talked about improving or expanding the diversity of EOVs with new optical backscatter systems that measure size and type of particle distributions, and talked about adding benthic sediment community oxygen consumption measurements, time-lapse photography, and changes that could be evolved with bioargo and long-range AUVs. So again, time was limited. Everybody got started on ideas on how to create relevant deep ocean observations to address these questions. Another group addressed the functional importance of deep sea animals and microbes. The key problems were identifying what is their functional importance in the deep sea and at the water column and at the sea floor, what environmental conditions these animals experience and how they vary in space and time, and how these variability influences their biodiversity and function. And I think underlying all of this interest is the realization that to create adequate environmental management at the deep sea floor, it's necessary to understand the functions and services provided by these ecosystems. This group talked about generating a series of transportable arrays, something like a benthic mobile observatory array that might include moorings and landers that can be deployed at sites to address these fundamental scientific questions, and then can be retasked or reformulated as scientific interests and questions evolve. They talked about utilizing existing deep ocean infrastructure to create a standardized series of measurements in different places to address the key benthic ecosystem questions. There was interest in focusing on nutrient cycling hotspots and in making measurements at representative deep sea habitats, for example, very high and very low productivity habitats. How to do this, always a challenge. They talked about enhancing connections among existing deep ocean observatories, developing new sites, maybe moving some of the ocean sites moorings to help address these questions. And everybody agreed, further discussion and perhaps a workshop was in order. And the final breakout group at this meeting addressed deep pelagic ecosystems with the goal of understanding ecosystem responses to climate change, deoxygenation, acidification, and human activities. The group wants to investigate the abundance, size, biomass of key ecosystem components. Many ideas about how to do this: video, sediment traps, acoustics, that talked about the need to establish baselines, time series observations, focus on hotspots, and to coordinate international efforts and to work across disciplines. Some of the measurements of interest are listed here: temperature, oxygen, so on, acoustics, egg and larval surveys, eDNA, and genomics. Again, these are just very initial discussions. They also took a look at what observing programs are actually out there that might be refitted to make measurements of the deep pelagic community, and they talked about adding biology to some of those you see here in red. And as you can see, there's quite a lot of of observing systems that could be refitted to go deeper. And then finally, I want to mention that there was just some discussion about trying to generate pilot programs that brought together many of these ideas. And one of the ideas that came up was perhaps creating a pilot study that integrated, at the very least, those last three breakout group ideas, the pelagic, the benthic function, and the carbon and flux measurements at a site in the Clarion-Clipperton fracture zone. These are manganese covered sites that are now being targeted for deep seabed mining. So there was interest in working with the International Seabed Authority on this. The goal would be to address multiple deep ocean observing strategy goals related to human impacts in the deep ocean, understand natural variations in carbon cycling and benthic ecosystem functions, and also to help advance the agenda of TPOS, the Tropical Ocean Observing System, which has been talking about moving a little bit farther north to address this region. So there are ideas of how these might contribute to each of the breakout themes, and I'm running out of time here, so I'm not going to talk too much more about that, except to say, there was some people in favor of having a sort of communal pilot site, and others really didn't want to see that happen. So more discussion is needed. So I'm back to the terms of reference. I'm not going to go through these again, but I hope I gave you a feeling about how these evolved. There was quite a lot of discussion. We've had input from many members of the science community who couldn't also participate in the workshop. And I'm really going to encourage any of you out there who want to have input to go on the website to look. Don't hesitate to contact us if you're interested in getting involved. There's a lot, I think, that will happen now going forward, now that there is sort of a set of terms of reference and objectives. There's going to be a lot of planning. We are seeking further input to the science questions and also to further engage the earth sciences community. We need to not only finalize the EOVs, I think there's still quite a lot of discussion that needs to happen about deep EOVs, how they may overlap or differ from the shallow water EOVs, and of course, detailed specs need to be made for these. We are going to, hoping to develop a task team to identify some of the observing gaps and emerging and new systems that could be promoted. We will be continuing to discuss the plan for pilot studies or other kinds of observation integration. This program will develop a science guidance and implementation plan. Any of you are interested in contributing to this, please let us know. And I think ultimately a technology roadmap for deep observing that will include tech transfer and capacity building issues. We're hoping to form a data team. If you're interested in that, let us know. That team will work on completing the ocean inventory. There's been discussion of conducting a deep data audit. That is, are the programs actually documenting what they say they are? And there is an effort to collate and post, there will be an effort to collate and post best practices for deep observing, much as what's been happening in shallow water. Communicating and coordinating is going to be a big part of this program. We hope to promote existing deep ocean observing opportunities to the science community to raise awareness of the importance of deep observing, both to the public and to policymakers at a broad range of venues. Hopefully this program will identify new linkages and conduct events with new kinds of stakeholders that haven't been involved in GOOS up to this point. And we hope to build partnerships and encourage the use of deep ocean observing data, including many intergovernmental organizations, some of the ones you see listed here. And I think that is my last slide. And so with that, I'd like to thank you all. If you're interested in getting further involved, please send a message to mccurdy@ucar.org, and happy to take questions and
thank you very
have
much,
a discussion.
Lisa. Really welcome your presentation. It was great. So the questions are open, and please feel free to start typing questions. And to kick things off, we have a few questions for you. So Katie.
Hi, Lisa. So just a question to kick things off while people are thinking up some questions to your presentation. So I guess different aspects of GOOS are likely to have very different readiness levels, and how do we ensure that GOOS develops in an integrated way, in a systems way, while taking into account these multidisciplinary drivers, while really capitalizing on these the developments, the observing aspects which are charging ahead, and is the best way really to kind of I guess take on a more iterative approach. So some things might charge ahead, but we might need to revisit how that connects up as other things move forward.
I'm not actually sure I can I address that question, except that I think you gave the answer, is that some things we're ready to do or we're already doing, and it's simply a matter of linking them up across programs. And other things are really important questions that are out there that we're still developing the technologies to answer. And I think I would like to see this program do both. Go with the mature observing technologies, but not limit it itself, because so many of these questions are going to be out there for the next 100 years. And if we don't work now on developing the technologies to address those, we're just going to slow things down. And I think this program, by linking up the deep observing community globally, is in a unique position to help push forward new technologies.
So we have a very pragmatic question from Bruce Howe, actually. Are you now seeking membership in the steering committee for this project, and what's the process?
I think, yes, we are. We have a list of a few people who've already volunteered, and of course we've heard most from the people who were able to attend the workshop. But the process is to send your interest to Andrea McCurdy. I think it's fair to say that there will be an effort to ensure representation from a wide range of countries, different disciplines, so that physics, biogeochemistry, and biology are represented, to ensure representation from some of the major sustained observing programs as well. So it's going to be a challenge. We may, if there's loads of interest, I suspect we'll end up with a good-sized steering committee, and that would be wonderful. So yes,
and,
anybody
who's
interested,
question.
Please
you talked
do
about
let
technology
us know.
roadmaps, which I think is great, and I think that's also important in the sense that a lot of the variables that you're identifying in the deep ocean are in some sense emerging. The feasibility of measuring them needs to be improved. Who do you think that those, I mean, who are the audiences for these technology roadmaps? Are they for academia? Are they for the research funding organizations? Are they for industry? How are you going to try to sell those technology roadmaps?
Wow, you know, I'm not even sure I'm the right person to answer this question. Maybe some of the people who are online out there would like to contribute some thoughts. You know, in terms of funding the roadmaps, I think getting industry aware of the needs is important. Yeah, I think funding becomes a struggle, but having major national observing systems aware of the needs for future development allows them, you know, I guess my hope is that you put the ideas out there and that there are agencies that can glom onto them. And in some cases, people can use their standard cruises and observing and add a little bit to test something new. And, you know, I think helping to facilitate, you know, if this program can help facilitate that, that would be a good thing. But in terms of how to fund and who is the audience, I'm hoping maybe the technology developers out there can help answer these questions.
And we have a question from Corey about whether the deep sea mining industry has been involved or is planned to be involved in this project.
Well, the International Seabed Authority has been involved. Sandor Motha was at the planning workshop, at the scoping workshop last month, and we hope to engage them because they are the recipient of large amounts of deep sea data in their claim areas and also can be the users of tremendous amounts of deep observing data. So that is the regulatory end of things. In terms of the industry themselves, at the international level, it's the states that sponsor mining, and but many of them have mining companies associated with them. And I think we would love to engage industry to the extent possible. So if there are people out there listening or have contacts and know how to engage them, I think that can be very helpful. I mean, we would love to see the deep sea mining industries engage in the observation needs and technology development.
Great, and Sandor Moslau is actually online listening, so so I'm sure there'll be some follow-up there. Just a couple. There's a comment from Venkat. He has asked, as chair of the International Tsunami Leadership, he's very keen for the Tsunami network to be part of the discussion. And there's deep sea temperature measurements close to the seabed, which he feels would be a useful contribution. And then a question around the space and capacity of platforms, noting the broad requirements for variables. How do we prioritize the deployment of sensors on those platforms in the deep ocean.
So the question is not about where the platform should be, but about which sensor should be.
How you prioritize sensor payloads, noting that sharing space and sharing platforms is going to be really important.
Well, I think the hope is that the group would work out the priority EOVs, and that with the intent that that indicates some hierarchy of priorities. But then my understanding is that there are quite a few moorings out there that are not at capacity, and that there is interest in adding new observing instrumentation to those moorings. I mean, this is what I understand from Uwe and Matthias, for ocean sites. And so maybe one of the things, by creating a network, a global connection of observing folk, we can help inform about available capacity on moorings. And if somebody's got a sensor that they'd like to deploy, we can help find a place for them to put it, and so on.
Katie alluded in her first question about the different levels of readiness for observation in the deep ocean, depending on the particular question, or the scientific question, or the societal question that we're trying to address, and the variable that we're trying to address. There is, in the deep ocean observing strategy, a real sense that science is going to be a big driver, and the whole exploratory aspect is also a big part of GOOS. Is there a deep ocean science coordination activity that exists that you can connect to, or is that not really developed as a kind of separate research coordination activity?
Well, I'm thinking that maybe the link should be INDEEP, which is a deep ocean. Well, let's think about this. So INDEEP is the biology program and is a global connection of deep ocean biologists. And other people have to tell me whether there is something comparable for the deep ocean physicists or the deep ocean biogeochemists. And if not, maybe the deep ocean observing strategy should help develop that. But I think the key here is to try to create an entity that brings together the physical, biogeochemical, and biological science communities to address these questions. And I guess that's maybe what you're suggesting with this question, right? Whether this is a goal.
When we look at GOOS overall, we're trying to deliver broadly for climate, for operational services, and for ocean health. And in the area of climate, we partner with the World Climate Research Program, and I think they are also the driver, in fact, for the deep observations related to climate, physical climate. In the area of operational services, we partner with WMO and with Godet Ocean View, which is a community of ocean forecast systems and the development of ocean forecast systems. And then in the area of ocean health, it's still a little bit open. There's a lot of potential players. There's IMBER, there's SOLAS, there's other scientific coordination activities, and that's an area that's still developing. So I was just coming back to whether there is a particular deep focus, and so that your answer about the biological focus on INDEEP is good to know. And we have a comment.
Well, INDEEP and DOSI, both of those really together.
And DOSI is focused a little bit more on the delivery of information for the stewardship, for the conservation, and for the sort of the human imprint in the deep ocean. Is that correct?
It is, but there are working groups on climate change and a variety, and other things that are not just exclusively human activities. Yeah. Well, that is, but indirectly. So, but yeah, between DOSI and INDEEP, I think that's a good biology component, but I don't think that addresses the non-biological science questions, and so necessarily. So creating and whether Future Earth or any of these other really forward-moving global programs will ultimately create the deep water science-based assemblage of people to address these, I don't know, but it could be that you're thinking about, well, who do we partner with to to spread the message, right? And to engage. And I'm not sure, I think that's a really good point, that we need to find the right organizations, and maybe some of the many people who are online listening to this have some ideas about
so there is a second International Indian Ocean Expedition, which is just launched and is going for at least 5 years. And apparently there is an area of concentration on deep ocean studies in the Bay of Bengal. So there's a regional science focus on the deep ocean in that part of the world.
Yeah, I think there are many regional programs. And so what I was trying to do is think of what there is in terms of a global program with the auspices of, the whole ocean across all the disciplines and sectors and jurisdictions. That's the real challenge. And scientifically, I think maybe we build from the ones we have and expand out.
Let me come back to the essential ocean variables, and you now have a list that is a little bit different from the list that has been put together by the GOOS panels, which are looking broadly across physics, biogeochemistry, biology, and ecosystems. I get a sense that some of these variables are specific to the deep ocean in terms of the deep ocean processes, but do you think that they meet right now the barrier, the threshold in essential of being feasible, or are these sort of emerging variables where you would want to develop some of these technology roadmaps so that they really do become feasible for broad scale observation, sustained observation in the future?
Well, can I move slides? Can I go back over to the... Yep, looks like I can.
Yep, we're seeing them.
Can people see these? Oops. So as you'll see, the green are the mature variables, and people can argue about how mature different things are. And sometimes you'll see the level of maturity, the same variables show up under different columns with different levels of maturity. But I think the point is that there are many physical and biogeochemical variables that we can readily measure right now, not so much for the biology. And you see many in yellow. These are things that people actually know how to measure, but they can't necessarily do it with commercially purchased instrumentation, or it's not easy to measure. So those are things called, they've been listed in pilot stage, and I think that that's an area where people could work very hard on these pilot stage EOVs to try to bring them up to mature level and try to make them very operationalizable, make them easy to use and ready to deploy globally.
Okay, so just a follow-up question. You partly maybe alluded to this earlier, but do you see that there are any particular low-hanging fruit in terms of observations that we can take to broaden the variables being measured in the deep ocean, i.e. Collecting additional water samples on ghost ship cruises, or leveraging ocean sites, which I think is one example that you mentioned. But did any specific examples come up which were really great opportunities? Forward.
Well, I think you've hit on a few of them. I think one of the things that became very apparent at the workshop is that the disciplines don't crosstalk very much. And a lot of the physicists didn't really understand what the big biology issues are that are being faced in the deep sea, and maybe vice versa. And so just that knowledge means that if there and it was also very clear that Ocean Sites was offering to make some of the standard EOV measurements in new places, because they have the potential to do that, to add deep water, salinity, temperature, maybe even oxygen, but salinity and temperature measurements in places we don't have them. And so by the low-hanging fruit is really learning where those measurements would be most useful and getting them made. And then I think having a community where opportunities, just if the community is more informed about what others are doing, that allows for a conversation about new instrumentation or new deployments and so on. And I think the deep ocean observing strategy is really just getting started. My hope is that we will have venues, town halls, and also workshops that allow more people to engage and to come together to try to find where that low-hanging fruit is, things that can be done without great added cost.
So we have a question from Jim Patemra, which is about, related to these EOVs, and particularly to the climate ones, has there been discussion about the required accuracy?
Right, and that is the answer to why an EOV might be mature in shallow water, but not in deep water. It turns out, and I learned quite a lot at this workshop, that it's not always that simple to even make a good temperature salinity measurement in deep water, let alone oxygen and everything else. And so because the levels of change are so small, the level of accuracy must be much greater very often in deep water. And those are challenges and things that people need to work on. And I think, having the EOV subgroups meet and discuss and develop the specs for each of these types of EOVs is going to be very important. They aren't going to look exactly like the shallow water EOV specs.
So let me ask you a little bit about the pilot project that you mentioned as a possibility in the CCZ, the Clipperton. Sorry, I can't remember the full name of it. Thank you.
Clipperton Clarion.
What are the things that would drive from the different disciplines and from the different areas that site particularly as an interesting place to go to?
So this was suggested by Craig Smith at the workshop, and I think that we really didn't have enough time to discuss whether it made great sense to put together all these different ideas and try to focus them there, but certainly Sandor was quite interested from the perspective of the ISA. So what drives this is the fact that first of all, on the bottom, the region is being there are claims in international waters, I think 19, or I'm not sure the number right now, 19 different claims for large areas for mining of seabed manganese nodules, polymetallic nodules. But beyond that, this region has an oxygen minimum zone sitting above it. It's 4,000 to 5,000 meters deep in many places. It's a subtropical equatorial region, sort of equatorial subtropical region. It's above the equator. And so there is just a lot of, it's a very high productivity region, and so there's a lot of interest for addressing many of the functional, deep pelagic, and I guess I should add that climate change is also expanding the low oxygen areas there and intensifying ocean acidification in those intermediate waters. And there's interest in knowing how all of that is going to affect the deep sea. So those are some of the motivators for that region. Maybe maybe Katie or others can tell us about TPOS, or Andrea, and what the TPOS interest is in that region. But I do understand they were talking about expanding there. Maybe I actually have it on the slide.
And so a lot of these areas, yeah, you have that red question mark on the previous slide in that area. But a lot of these areas that you're thinking about working in are in areas beyond national jurisdiction. Much of the deep ocean is, but not all of the deep ocean, of course. Can you imagine how the cooperation, sort of funding-wise and deployment-wise, between countries might work in an ideal GOOS, a deep ocean observing system, rather than strategy?
I guess at some level it's easier when you're beyond national jurisdiction. Right now, there may be fewer restrictions on data gathering, especially biological sampling and things like that, although there is a new international treaty on biodiversity being developed. funding-wise, the big problem is nobody's responsible for that. Even the UNFCCC has no jurisdiction over carbon emissions in the, in the high seas and international waters. So on the other hand, everybody realizes that it's one ocean. It's not two oceans, an ocean within EEZs and an ocean beyond EEZs. And so I think that there are already many observing programs that have sites in international waters. I think people have to, I guess it will be national funding that has to prioritize the big science questions that require making measurements
in your past experience.
Yeah. And at the intergovernmental agencies, I should say.
I mean, in your career, have you seen some really successful examples of where countries have really pooled resources to build a bigger research and observing program than they could have individually?
Well, certainly the EU has done that with Atlantos, and there are some other EU programs. Maybe if Henry's on, he can talk about those. I think the TPOS is certainly a multinational effort that's addressing big, important equatorial programs. So the GOOS programs themselves are good examples of this. There are probably many others that I don't know about right now. I think that as academics slowly begin to understand that they should be engaging in policy and management, we may see more and more of these collaborative efforts happening.
Yeah, well, you've given
can you
some
think of
pretty nice
some
examples. Argo is also a pretty nice example in the sense that funding is held nationally. The PIs are funded by their individual national organizations, but there is a real effort to coordinate all that together and to make up for gaps and changes in funding between different countries.
And GoShip also, I think, is a very proactive collaboration where they're reaching out to new countries to engage and participate.
But it's a constant sales effort.
Yeah, I mean, in fact, Argo and GoShip are the best examples. I mean, they are global and they are perhaps a model for how we can
Maria
do
Baker has brought up
other and more advanced observing.
Yeah, well, Maria Baker has brought up the example of
the first things
marine
I
life
mentioned
as an example of really pooling national resources for a big 10-year program. Bruce Howe has a question about the lack of earth science input or sort of geophysical input at the workshop. Is there a particular plan to entrain that community beyond the tsunami aspects?
I would say the plan might involve asking Adam Soule and Bruce Howe how to best entrain this community by getting these folks on the steering committee and then getting them to work with the earth science community. That is the plan. But we're open to ideas.
One of the special characteristics about GOOS is the fact that the deep ocean really is under observed, and there is a really strong exploratory aspect still to going to observe in the deep ocean, and that does capture the imagination sometimes. I'm just trying to make the parallel in astrophysics. There's a lot of success in developing really big and expensive infrastructure to look at deep space or to look at particle physics. Do you think there's something that this community can do to replicate that kind of success? Is our ask maybe too small here?
I think we haven't developed the ask yet. I think the program is nascent enough that we're still trying to figure out what should the priorities be and how should those be achieved. I think you're right that capturing the public's imagination is something that this program ought to be able to do. It's not hard. People, if you look at the telepresence programs, they have millions of followers. People love to look at the deep ocean. And I think that trying to incorporate that into some of the efforts can be very helpful in terms of engaging and maybe finding funding. So, but I think that it's yet to be determined what the big ask should be. And I think
we should be putting cameras on deep Argo floats? Yeah.
possibly. I mean, there is definitely talk about putting cameras on moorings to address some of the major questions anyway, and so the question is what, and we have we have deep water observatories that we hope are part of this program that routinely have cameras taking imagery, and they are available online all the time, and many people don't know about it. So part of what we need to do, I think, is gather up this information and really work on outreach and communication and engaging more of the world in observing the deep ocean.
Okay, Lisa, we've pretty much come up to the end of our time. And so I would just want to take a moment to really thank you for your efforts in the past to help develop this deep ocean observing strategy and your presentation today. And you've had a big and pretty involved audience. So I think that's a reflection of the broad audience you do have actually for this program. So thanks very much. And keep a look on the GOOS website or sign up for the GOOS news for the announcements of the next webinars. Thank you, everyone. Bye-bye.
Bye.